Okay, so let's take a look at the second question. That's a classic one. So we've got a person here, right? And she's standing on basically the vicinity here of a vertical cliff. So she throws a stone upwards. That stone will basically stop at some point and then fall down to the pit. So the stone leaves her hand with a speed of 15 meters per second upwards, right? So it starts with some upwards velocity. At the instant, her hand is 80 meters above the surface of the sea. So that's it. Okay. Air resistance is negligible and the acceleration of free fall is 10. So you don't have to use 9.8 for this question now. Calculate the maximum height reached by the stone as measured from the pivot point where it's thrown. Well, what we have to remember here is that the acceleration which is going to stop the stone from going upwards is gravity, right? It's going up, but it's slowing down as gravity is pulling it down, and then eventually it will start falling down. So if we're trying to look for the maximum height, we have to look for our SUVAT equations and then find out which one is going to give us the displacement, right, in terms of things that we know. So we know our initial speed, so let's use the same variables that we have been using in our classroom. So initial speed, usually we have been using u, so 15 meters per second. Now if the stone moves upward up to a certain point, when it reaches its maximum height, we know the velocity there, right? We know that when it stops, the speed will be 0, because then it will start moving downwards, so it has to stop at some point. So we know that our final velocity is 0. We know our acceleration, which is 10 meters per second, and now we have to look at our SUVAT equations and find which one is appropriate for us. Now for this problem with those unknowns, what I would pick is v squared equals u squared plus 2as. So v final velocity, u initial velocity, a acceleration, and s displacement. We're looking for displacement, so we have to rearrange this equation. So if we rearrange this, we'll have v squared minus u squared, and we divide all of this by 2a. Now this is one of those would be 0, right? And this is just a frame of reference. I will get a negative value, but it doesn't matter. It just means that I'm counting positive in the opposite direction. So this is 0. So if we put numbers in, this would be 15 squared over 20. So that's 225 over 20, which is about 11 meters, up to two significant figures. Now notice here that I've just dropped the sign. Why? Well, I had a negative sign here and my acceleration. If I consider my reference to be positive upwards, then my displacement would be positive, but my acceleration would be negative. Therefore, this would be negative here, and then I would cancel out both signs. If I decided my y to be positive downwards, my acceleration would be positive, however my displacement would be negative. We would get to negative 11, and that would mean that we're going opposite to the direction where y is actually pointing towards. So let's go for the next item. So, determine the time for the stone to reach the surface of the sea after leaving Lucy's hand. So now what we're looking for is not only the first motion, which is going up and stopping, but also that one which is completely down. So we have realized that this displacement upwards from her hand was 11 meters. But we knew that she was standing 80 meters. Her hand was at 80 meters from the bottom of the pit. Therefore, this total height here that she'll have to overcome is actually 91 meters, right? So there will be this first motion upwards for 11 meters, and then this downward motion for 91 meters until it reaches the bottom. So this is actually fairly simple. We can split this into two different motions. So the first one, which is upwards, the second one, which is downwards, and we find the time for each one. So t for going up and t for going down. And then we can just add those times. So how much time does it take for the stone to reach its topmost position? Then we have to look for our CUVAT equations again. So I've put them here, right? Our CUVAT equations. So which equation would be the most appropriate for us to use just in order to solve this question, right? So we're looking for time now. So this one won't do, right? And basically, if we're going up, do we know initial velocity, final velocity, and acceleration? Yeah, so we can use this one. So if we want to find time in the first motion, we can just do v equals u plus at, and then, well, since this is 0, right, so u would be, we're looking for t. So t would be negative u over a, and then again, this is negative, right? It depends on our frame of reference. So because they are in opposite directions, that's why there's this negative sign. So negative u, so that's my initial velocity, which was 15. Okay, so minus 15 over minus 10, because if I'm assuming that my frame is positive upwards, then my acceleration is negative. So this would be 1.5 seconds. So that's how much it takes for the first part of the motion. Now for the second part of the motion, I believe we could use the same equation, right? Because we know initial velocity, which is 0, we know final velocity, and we know the acceleration. So, oh no, in fact we don't know the final velocity, so we cannot use this first equation. However, we know our displacement, we know acceleration, we can use this one, right? So S equals ut plus at squared divided by 2, right? So initial velocity for the movement downwards will be 0, because it's still when it starts to move, when it starts to be pulled down by gravity. So initial velocity is 0. Acceleration, we know that this is 10, and we're looking for time. So time squared would be 2s over a. I just rearranged this. Therefore, time is square root of 2 times displacement divided by the acceleration. So 2 times the displacement. The displacement is 91 meters, because it's the total all the way from where the stone has reached the highest position all the way to the bottom of the pit. So 2 times 91 divided by 10. And this would be about 4.3 seconds. Okay, up to, again, 2 significant figures. So the total time would then be, you add those two, 1.5 plus 4.3. So this would be 5.8 seconds. And that's done.